about the engineering controls that you can use when you handle chemical. We'll talk basically today. We'll talk about two applications. One is chemical handling. The second one is engineering control for chemical storage, right? So chemical handling, as we know, most of the lab will sometimes we'll see this happen because there's too many students or too many experiments. They have to do it on the bench, right? So they have to do it on the bench. Of course, they will have risk. They do not have enough engineering control system or fume hoods, right? So and sometimes we also see like certain equipments. Okay, we putting on the bench that equipments that generate vapors. Or occasionally we'll see also measurements of toxic powders at the open bench. That is also a concern. Of course, if you measure DCM, the dehydrated cultural media is still fine. But if you are measuring, carcinogenic powder, then maybe you should do something on that, right? So the best solutions to protect you from these chemicals is by having a fume hoods, right? Fume hoods, also called kabut wasap. There is actually two options of fume hoods, and they are ducted and ductless fume hoods. All right. So the ducted fume hood is basically, we call it LEV, local exhaust ventilation, because it has 5 components. Because DOSH specify a ducted fume hood should have 5 components. The LEV should have 5 components. The first one is the hood, and then the duct, the air cleaner, the fan, and the stack, which is the chimney, right? So that is the ducted fume hood, LEV, all right? So whereas for ductless fume hoods, because a ductless fume hood, from the name it doesn't has the duct and also the chimney. So it basically has a hood, the fan, and also the air cleaner, which is the carbon filters or HEPA filters, right? So we call that engineering control systems, all right? So so these tools is the options that you have, but I believe you already observe most of the things that shows here are in a box. Is a box-like equipments, right? So why we need a box, right, to handle chemicals? Why not we have something like this, a suction arm or canopy? We would not say you cannot use, but I will say it's not sufficient to draw out all the contaminant. Why? Because there is no containment. Because when you open up the chemicals on the open bench and your suction arm is at the top, maybe the suction arm can only withdraw 60% or 50% depending on the distance, right? So 60% of the film, but the remaining will go back to the room, or you will inhale it. So that's why we say it's not that safe, right? If you use the suction arm or canopy hood. There is a place where you use canopy hood, especially when you handle heated film, like those that AAS system, furnace systems. Those systems you should use a canopy hood, all right? So because you draw out those fume and exhaust outside, right? So why we say that when you handle liquid chemicals in the room temperature, the suction arm is not that efficient. Why? Because of this concept, the Graham law. The air molecules or the chemicals are very light. So once you open the bottle, the lid, the chemicals vapors will spread in the split of second. So even before the suction arm can withdraw them out, they already spread into the lab. That's why you put yourself in a risk. So that is the reason why most of the fume hood looks like a box, because we want contain. We call that containment hood. The chemicals should be released inside the box. And I would say, if you're using fume hood, make sure any handling is inside the hood, and the distance from the such opening should be 6 inches and further, right? It shouldn't be too near to the opening, right? So that's why we have air velocity, right? So when we open up contaminant chemicals in the film, in a box, like fume hoods, So we make sure our airfare velocity at the opening is 0.5 meter per second and above, right? So if you convert to feet per minute, it will be 100 feet per minute, 100 feet per minute, right? So this is the minimum requirement for any fume hood, be it the ducted fume hood or a ductless fume hood. Maybe some of you will say, if I increase the air velocity, that would be better. Example, I increase to 1 meter per second or 2 meter per second. Would that be better, Joseph? Actually not. Okay. Why? If you increase your fan, your air velocity to 1 or more than 1, is not good. Because especially for ducted fume hood, you have a very narrow duct. Okay, maybe 10 inches or 12 inches duct. So if you increase your fan speed, you increase the air velocity, what will happen? It will be, the air will try to squish into a small duct and tend to have, turbulence inside the fume hoods. If you have turbulence inside the fume hoods because the suction is too strong, it tends to leak up as well. So it doesn't mean that you have a strong air suction, it will be good. No, okay? You should be within 0.5, or sometimes for ductless, it can go to 0.4. The most is maximum is 1 meter per second. Actually, DOS says that 0.5 to 1 meter per second. All right. So why do we need to have 0.5, right? So because when we have 0.5, when we have some minor changes in pressure, the room pressure is, we can contain the chemical in the fume hood. But there's two scenarios that we need to take notes that we shouldn't do in the lab. Okay, you can advise your clients or you can advise your colleagues is don't run across your fume hood, especially when your fume hood is handling, chemicals. What will happen if you move swiftly through across your fume hoods? This will happen, like what I showed in this video. You are creating an aerodynamic, and you are basically draw out the chemical because you create a vacuum. So the chemical will be sucked out and leak out from the chemical from the fume hoods. So you can't see it, but I think this graphic will show it to you clearly, right? There's also another situation that you shouldn't do is try to open your sash quickly, right? So you quickly open up your sash, and this will happen. The chemical will be directly exposed to you, especially when you exceeded the level that is safe, right? So make sure you remind your colleagues shouldn't do that, right? So, but anyway, if you have 0.5 meter per second up to 1 meter per second, you are safe in the situation of open and close the door, because when you open the door, the room pressure changes a little bit. So it's fine if you have 0.5. You shouldn't be, the chemical will not leak up, right? Or sometimes the air condition system, we also not affect if you have, you will not also not cause the chemical leakage because you have 0.5 meter per second, right? But one thing you have to remind your colleagues, should never blow a fan towards the sash opening. I do see some of the lab, they do that because the lab is very warm, so they have a fan, standing fan, and then they blow it in front of the sash opening, and they can't reach 0.5 meter per second if you do that. Okay. So there's the key factors when you consider fume hoods, be it the ducted or ductless. The first one, of course, is the regulations. This will be a very basic introduction. If you want more of this information, of course, you can talk to your CHRA and also your hygiene tech tool, right? So I'm comparing the ducted fume hood and ductless fume hood so that you can have an objective understanding of what you should consider when you go for ducted and when you go for ductless. There's a few regulation here, basically the DOS regulation and also DOE regulation. The DOS regulation is the use regulation I mentioned early in my presentation. For ducted fume hood, every year is compulsory for you to run the LEV test, right? To run the LEV test. Of course, the hygiene tech tool is the person that should run the test. they will have to check this, the FS velocity at the such opening, and also the duct velocity, the static pressure, and they will prepare the report for you. All right. So this is compulsory, and from my understanding, I think after 2014 or 15, all the newly installed ducted fume hood should have an air cleaner as well. Okay, should have an air cleaner before the fan, right? So for ductless fume hoods, it's not compulsory, but observation industry customers will do the LEV test as well. Basically, they will check the FS velocity, they will check the fan speed. Then basically, it's easier to run the test, LEV test for ductless fume hood. The price should be cheaper, all right? So that is DOSH compliance. One more thing, of course, ducted fume hoods, your duct design has to be approved by professional engineer, all right? Whereas for ductless, there is no duct, so there's no need to comply to this specific requirement signed by PE. Basically, what you need is to prove that your ductless fume hood has complied to international standards, example like XRAY, CEFA 9, NFX, and etc. Right? These standards actually validate the ductless fume hoods. Now let's go to the DOE. Okay, we have two regulations here. The first DOE is the Clean Air Regulation, which govern the chimney. With layman term, we call it chimney license. So when you install a ducted fume hood, at the first 30 days, you should submit your application to the state DOE by the competent person. DOE competent person is not Hygiene Tech 2, but the DOE competent person. The typical cost will be for 4,000 to 8,000. Okay, and you also need to do emission tests as well. Okay, so that is the requirement for ducted fume hood. And for a ductless fume hood, there is no chimney, there is no discharge of chemical outside the building, so there's no need to comply to EQ, the environmental quality clean air regulation. Then we go to the next DOE regulation, which is the schedule waste regulations. I made a mistake here because for the ducted fume hood nowadays, due to the regulations, you also need to have clean air, which is the carbon filters before the fan. So which means that carbon filters is a used filter and also classified as schedule waste. The code name is SW410. Code SW410. All right. So which means be it a ducted or a ductless fume hood, you need to handle the used filter. Okay. Or maybe you can ask the vendor to handle for you. Right. So that is the regulation part that you need to consider, the first part. Then the second part is the facility, the structure. Where the building, does it has enough makeup air to come into the lab, and then you draw out the air when you have a ducted fume hoods. You need to make sure you have enough makeup air so that your pressure in the room is at the it's not too negative. You would not feel like not enough air to breathe. So that's important, right? Be the duct and ductless fume hood as well, you need to also make sure the system has gone through a contaminant test. I will show a video here, a short video here, to show you how they do a contaminant test. What is the contaminant test? Is basically they want to make sure the chemical that release inside the fume hood will not release out. So they are challenging the fume hood using a very light chemical, which is a synthetic chemical called SF6. The SF6 will be released in the fume hoods, and they will check at the opening, see whether the reading has exceeded 0.05 ppm or not. If you exceeded 0.05 ppm, which means you failed the contaminant test. The problem for the ducted fume hood in Malaysia, especially the local make ducted fume hood, is they do not run this contaminant test. So that's why you have some question marks whether there is a leakage or not, right? So let me show that. We start with the smoke test. You can see the pattern of the smoke. So on your right, the red color is not efficient. On the left, the green color is efficient. So this is the SF6 setup. They release the SF6 and then they use a sensor to test it. So everything is below 0.05 ppm. So there's no alert, it's safe. Now he move on to another one. Look at the readings. Exceeded 0.05. Okay, so obviously this is fail. They failed the contaminant test. So this video I took from the internet. The sunway here is not the sunway pyramid that we have in Malaysia, right? Just to make sure, right? So that is for be the ducted fume hood or ductless fume hood. You have to go through this contaminant test, and especially those international standards like ASRAE, CEPA 9, NFX, 15211. All these standards they already require the manufacturer to go through this contaminant test. If the fume hood has complied to these standards, so you confidently say that they have passed the contaminant test, right? So let's talk about the ductless fume hoods. The ductless fume hood as well, you need to comply to the the contaminant test. You need to comply to regulations. So when we talk about ductless fume hoods, the contaminant test for ductless fume hood is perfect. Not most of the time is 0.00 ppm. But the challenge for the ductless fume hood is basically you need to make sure the application that you use inside the ductless fume hood is suitable. The air cleaners, the carbon filter that used in the ductless fume hood is compatible with the chemical that you handle. All right. So most of the time, the vendors should do a validation before they sell you the system to validate, whether your application is suitable or not, and how long you have to change the filter. So I would say the filter frequency change more than 6 months or less than 6 months is considered not feasible. All right, I repeat, if the validation came out and it says that you need to change your filter every 3 months, I would say ductless fume hood is not feasible for you. All right, you should go for ducted fume hood. But if the validation came out says that your filter can last for 1 year, and the vendors should check, most of the time we will check whether the filter is saturated or not. All right, so more than 6 months or to 1 year or 1 year plus, I think that is feasible. That is feasible. Okay, so I hope these parameters will help you to make wise decision. This is the list of the reason why people go for ductless fume hoods. I talk about this more because not many people aware about ductless fume hood, or know at what situation you should choose a ductless fume hood. All right. So the ductless fume hood may not be more expensive than ducted fume hood, right? It could be cheaper, but make sure you know when you choose a ductless fume hood and when you choose a ducted fume hood. There's a few reasons here people choose for ductless fume hood. The first one, of course, there is not enough makeup air in the room. As I said just before, there is not enough air in the room. If you put another ducted fume hood, it draws out more air and make the room become too negative, not enough air to breathe. In this situation, the best option is go for ductless fume hoods if you need additional fume hoods, right? Number two, When the laboratory has no structured access to install ductwork, I do have come across customer like this because they have too many duct outside, a chimney outside. There's no place for the additional chimney. So in this situation, they will go for the ductless fume hoods, right? Number 3, when the lab lack funding for extra ductwork, because ductwork is not cheap, you have to go for DOE. So upfront investment is quite high. If you want, it's very expensive, so not justifiable to go for ducted. May as well go for ductless. Number 4 is the lab has no intention to comply to the clean air regulation, the chimney license. All right. Number 5, the cost of building infrastructure, retrofit, and to install a new fume hood is prohibited. Okay, not approved. Right. Number 6, the management want to save energy and operating costs in long run. Okay, I want to explain this clearly. Ducted fume hood is the most energy consumed equipment in the lab. Okay, let's give you a perspective. A 5 feet ducted fume hood, it draw out maybe 530 cubic feet per minute of air. If you on it like 4 hours per day, 5 days a week, then I estimated the cost of electrical bill, just the aircon bill to cool down your room will cost you 700 to 900 ringgit per month. 700 to 900 ringgit per month for a ducted fume hoods, right? Whereas the ductless fume hood, because it recycle, it doesn't change. The energy consumption is much lower. So when the number 7, when the laboratory is going to sustainable, environment friendly or green index building, we do have customers like example like SunPower, where the whole factory is platinum green building index. So they go for a ductless system, right? So let's move on. These are some of the example. All right.